Let us see another problem from the topic work done. A fluid at pressure 3 bar and with specific volume 0.18 meter cube per kilogram contained in a cylinder behind a piston expands reversibly to a pressure of 0.6 bar according to a law P equal to C by V square, where C is a constant. Calculate the work done by the fluid on the piston. So here a fluid at a pressure of 3 bar, that is pressure is given as 3 bar, and specific volume, it is clearly given specific, and also the unit is meter cube per kilogram. Therefore small v is equal to 0.18 meter cube per kilogram contained in a cylinder behind a piston expands. So this is the initial state, so I can give it as P1 and V1. Now this is expanded reversibly to a pressure of, that means P2 will become 0.6 bar, and while this expansion process is happening, it follows a relation P is equal to C by V square, where it is given that C is a constant. Now what we have to do is, you have to find what is the work done. The key to this problem is understanding this equation P equal to C by V square. Does this equation seem familiar? You have to, because this equation can be written as P, V can be taken to this side, PV square is equal to a constant. Now what is this equation? PV square equal to constant means this is of the form PV raised to N equal to a constant, which is a polytropic process, So identifying this problem as a polytropic one is the key to solve this equation. You can solve it by using W equal to integral P dV, and by giving the value of P in that integral P. See, just like the last problem, I can give it as W equal to integral 1 to 2 P dV. This is P, this is an equation on P, so I can just substitute C by V square into dV and solve the equation. That is fine. But I don't need to go into that distance. Instead, if I can understand this P equal to C by V square is equal to PV square is equal to constant. That is, if I take V square to this side, it becomes a polytropic process. Therefore, I know the work done in case of a polytropic process. In case of a polytropic process, the work done W is equal to P1 V1 minus P2 V2 by N minus 1. You can see that we have the value of P1, we have the value of V1, we have the value of P2, but we don't have the value of V2, and we have the value of N. Here N is equal to 2, which is the polytropic index. The only thing right now I don't have is V2. Again, it's quite easy to get, because I clearly know that it is a polytropic process. Therefore, from this polytropic equation, P V raised to 2 equal to constant means P1 V1 raised to 2 is equal to P2 V2 raised to 2. All these should be equal to constant. Therefore, I am taking this term. I can take P1 V1 square is equal to P2 V2 square. Therefore, V2 square is equal to, I'll take P2 this side, P1 by P2 into V1 square, small v. It's always small v here in this problem. So here I can see that V2 is equal to root of P1 by P2 into V1 square, and you get this value as 0.402 meter cube per kilogram. Now substitute it here. W, small w, because it's per kilogram, is equal to P1. P1 is 3, therefore 3 into 10 raised to 5, right? It is 3 bar, that means it is equal to 3 into 10 raised to 5 Newton per meter square. So into, it is V1, V1 is 0.18 meter cube per kilogram. Thus minus P2, what is P2? 0.6 bar, 0.6 bar means 0.6 into 10 raised to 5 Newton per meter square, therefore it is 0.6 into 10 raised to 5 minus V2. I have already found it is multiplied by 0.42 meter cube per kilogram. Here 10 raised to 5 is common on both sides, so I'll take it outside. 3 into 0.18 minus 0.6 into 0.402. This whole divided by, it is n minus 1, that is 2 minus 1. Therefore, this will become, if you solve this one, you will be getting it as 29880. This is divided by n minus 1, so that n minus 1 has to be taken. See, P1 V1, this is the P1 V1 minus P2 V2 by n minus 1. N minus 1 is, n is 2, therefore 2 minus 1 will become 1, and this unit will be, or the value will be in joule per kilogram. The unit is very important. The work done W is equal to 29880 joule per kilogram.